Hello, everybody. Welcome to a new episode of the Dissenter. I'm your host, as always, Ricardo Lopes, and today I'm joined by Dr. Gareth Leng. He was one of the founders of the British Society for Neuroendocrinology. He was also Chair of Experimental Physiology at the University of Edinburgh. He is also a former editor-in-chief of the Journal of Neuroendocrinology and a former president of the International Neuroendocrine Federation. And today we're going to focus on his book, The Matter of Facts, Skepticism, Persuasion, and Evidence in Science. So, Dr. Leng, welcome to the show. It's a big pleasure to everyone.
Thank you very much. I'm looking forward to this.
So I would like to start our discussion by talking a little bit about evidence, because as you go through in the book, perhaps people who think about science usually tend to think as evidence as something that is fixed. So we look at it and we know what it is, and it has one single interpretation, but that's not exactly how you talk about it in the book. So what is evidence?
That's a great question. This is really at the heart of it. It's a very, very important question. I think people often think that evidence is neutral, it's unbiased, it's just out there. You go and discover it. People talk about the evidence should speak for itself. Well, evidence never speaks for itself. Evidence always has to be spoken for. Evidence, for a scientist at least, is always evidence for something or against something. It's always for a claim or in contradiction to a claim. There's no such thing as neutral evidence. They're just observations. They're not evidence. And we normally think of evidence has to have some connection with the real world, either consists of observations or experiments, but it's tightly linked with a claim, always linked with a hypothesis.
So can we say really that evidence has ever been found, or is it rather interpreted?
Well, sometimes it's rediscovered, but evidence is always, if you like, interpreted. Evidence is the ammunition that scientists use to persuade other people. Well, it's part of the ammunition. You know, it has a rhetorical purpose as well as an objective purpose. You know, it is an instrument of persuasion. That's not to disparage it. You know, as scientists, we work with evidence, but we have to remember always that it is a rhetorical tool in the way that scientists use it.
And when using evidence, should we expect it to yield exactly the same conclusions independently of the context, or does it depend on the context?
Well, clearly not. I mean, you find scientists using the same piece of evidence to support very different claims quite often. It is, as I said, evidence can be used in different ways by different people, and it is used in different ways by different people. So.
Mm-hmm. And of course, at a certain point there you mentioned persuasion, and it's also in the subtitle of your book. So is science really the result of, let's say, a pure process of reasoning, or does it also include persuasion, and to what extent?
Well, I think persuasion is at the heart of it. It was really a Frenchman, Bruno Latour, who wrote this wonderful book called Laboratory Life back in the 1970s. And he was just a young scientist at that time. He wasn't really a scientist, he was a socialist scientist. But he spent a year in a laboratory in the Salk Institute, just observing what scientists were. And it's a lovely book, and it's got very kind of simple, insightful understanding of it. Because what he saw was that whereas scientists thought that they were in the business of discovering facts and interrogating nature, what he saw was that, well, actually they were just in the business of convincing other scientists and being convinced by them. And it was all about that. And it was about they struggled to make their claims stronger and to weaken the claims on the other side. It was all about argument and all about persuasion. And evidence was part of the ammunition they used for this, but only part. They also used rhetoric and all kinds of tricks to increase the persuasive power of their claims.
Mm-hmm. So, just to wrap this bit up, I guess, it is really not that idea that many people have, that scientists do things and they sort of observe objective reality, and whatever kind of results they get through empirical testing or whatever, they would yield you definite conclusions that need no interpretations. And even if it was done without, I don't know, any human intervention, I mean, the knowledge would be there and it would be about objective reality.
It's
That's
far
not
from
how.
far from it. Now, science for a scientist is a very constructive, creative process. And that's what makes it so exciting for scientists, that they're constructing an idea, a hypothesis, they're building it, they're gathering evidence for it, and they're trying to persuade people of it. In the end, scientists are people. They like to be listened to, they like to persuade people, they like to be believed, and they like to have this kind of imaginative, creative role in constructing the knowledge that we have. So I think it's an illusion to think that science is a cold, objective reality out there. It's not. It's a human endeavor.
And does science have a defined structure?
Well, it depends. It depends upon the field, of course.
Okay.
And it has no single structure. And different fields of science are very different, of course. And my own field is biomedical science. And we have our own conventions and we have our own structures, but they're very, very different from the structures in other parts of science. And even within a field, there are subgroups and subfields that have their own different conventions. So there is no common structure. And the structures that we do have are changing all the time anyway. And the rules by which we work are shifting, and everything that we understand is shifting gradually.
But is there a set of norms in science and across the different scientific fields?
Well, individual scientists will have norms. Many of them are shared by other scientists, but often the reality is that these norms are not enforced. And quite often they're sort of lip service paid to them. I mean, I think Merton has set out famously a set of norms for science, and they're a kind of wonderful idea, and that they are noble aims. I think that science is a communal exercise, that it's shared for the good of all. In fact, we know that actually science is intensely competitive, and one of the famous examples we talk about in the book is of the race for the Nobel Prize between Andrew Shalley and Roger Guillemin. Well, actually, they were both trying to do the same thing, be the first to it, and they detested each other. They refused to cite each other. They refused to collaborate with each other. It was an out-and-out war and competition between those two. And so certainly the idea of science being a communal enterprise, well, it's true for many people. I mean, I always loved collaborating with people, but others were very kind of jealous and single-minded and really wanted to keep things quiet until they had exploded a story. So there is no kind of common norm there. I think if there is a commonly held norm, it would be that science is about organized skepticism. And that the questioning of findings is something that we kind of value it. And I think everybody understands it's important. Everybody understands that kind of doubt and argument is an essential part of science. But even there, sometimes we feel that even that is discouraged. I know when I started as a young scientist, it was exciting, the arguments and the intense dissension. You couldn't speak without being exposed to criticism. Well, times changed, and now actually people think you shouldn't be unkind to other scientists. You should listen politely and not argue sometimes too openly with them. So things change, and norms are very much an individual thing, I think, now.
Mm-hmm. And is science planned or self-organized?
It's chaotic, really. It's organized chaos. I think attempts to kind of plan science. Look, I shouldn't generalize. There are some fields where it does look as though organized planned science works very effectively.
Yeah.
And that's true. But in general, curiosity-driven science is semi-organized chaos, I think. I think it has to be. I mean, sometimes people are tempted to think that we should direct money to things that are important, and we should fund a drive to solve some great medical problem or some scientific problem and all that stuff. Generally, I think those drives fail, or they only succeed at enormous expense, and that's because these big problems are problems because we don't know where the answer is. And the answer can come from anywhere. And if you don't have a very diverse, chaotic expression of kind of discovery and looking, you may not find the answers because they're hidden in quite unexpected places. If you try and plan science, you'll follow down blinkered tram lines, if you like, predictable paths, and predictable paths probably usually don't lead anywhere interesting.
Mm-hmm. So when talking about science, many times people tend to use the term scientific method, but is there one single scientific method?
Well, it certainly isn't, I think. It'd be nice to think that there was, and there've been some, Popper we've talked about kind of held up a kind of model of an ideal scientific method. In fact, it is more like what Feyerabend's view, which is that, well, anything goes, really. Anything goes that works, and what works for a scientist is any activity which will help them persuade others of their claim. It's as simple as that, really. So anything that adds persuasive value to a claim becomes part of the scientific method for a particular field. Of course, in a particular community, there are conventions, and so those conventions mean that some kinds of evidence are going to be more persuasive than others. Some will be accepted and some will be dismissed or not understood. And so in any particular community, of course, there are these conventions, but those conventions change over time as well. But those conventions really define what kinds of things will be part of a persuasive argument. And they're different from field to field.
Mm-hmm. And what do you make of Thomas Kuhn's idea of scientific revolutions and we moving from one paradigm to the next and that kind of thing?
Well, it's a lovely book. I mean, it's an absolutely glorious book. It's one of the. I mean, I started out as a mathematician, and it was one of the books that I read even as a mathematician. I thought, gosh, this is paints such an exciting picture of science that I want to be part of it. And it's one of the things that brought me into science. I think we now see that actually there are kind of constant small revolutions in science. We don't call them, it's not a revolution like a big earth-changing turmoil and everything collapses and everything's built up again. But as you're working as a scientist, you do find yourself working on an idea, on a theme, and then at some stage it always goes horribly wrong and it dissolves and people don't work on that anymore and they shift onto something else. And you look, in retrospect, you can understand that as being a revolution. Something happened to change people's mindset and this problem was no longer important or interesting or the idea was false. So this kind of thing happens all the time. Kuhn's book was really kind of very insightful in lots of ways. Now he had at the center of it was this idea of a paradigm, but the idea of the paradigm as Kuhn used it changed. I mean, he used it in many different senses at different periods of his career. And so it's something that's still very hard to pin down. In a sense, when you talk to people about paradigm, you tend to share an understanding of what you're talking about, and so you can communicate, but it'll be different in different contexts. So when I think of a paradigm myself, I think of, if you like, the accepted style of doing science in a particular field. It's a framework that defines what kinds of techniques are appropriate to answer the questions. It defines what are the important questions. It defines what are the kind of accepted tenets of knowledge. It is this complex framework. That's the paradigm. And the paradigm can break down and change for lots of different reasons. It can change because of an anomaly, and of course that's what Kuhn drew attention to, because of anomalies where the idea is somehow is wrong, it's fundamentally wrong. But it can also change because of a technological revolution. A different method has become possible. And so suddenly the old questions don't become interesting anymore. And so suddenly the field changes towards addressing the things that can be addressed by new technology. So there can be lots of things that break and change the paradigm.
Could you give us one example of a paradigm change?
Well, I can give you good examples and bad examples. Yes.
Okay.
Well, I can give you a very good one, I suppose. In that is an example of, in my view, of the emergence of a really terrible paradigm. Well, about 20 years ago, psychology was running into problems. And the problems it was running into is that psychologists wanted to talk about what was happening in the brain, but they had no investigative ways for changing what was happening in the brain. And really, that was key. If you're going to do an experiment to do that, you need to somehow change brain function. Well, there was a story emerging from animal work that this hormone oxytocin was released into the brain and could affect social behavior, complex, interesting behaviors like that. And psychologists caught on to that and said, if we can do something that alters oxytocin levels in the brain, then we'll be able to alter social behavior and we'll be able to do interesting psychological experiments. And they cottoned on to the idea that if you give a very large amount of oxytocin intranasally, squirting it up to the nose, then it may get into the brain and we can observe what is going on as a consequence of that. Well, this triggered a massive amount of investigation. For the psychologists, this really was a paradigm change. Suddenly, it seemed to become possible to use a completely novel experimental approach to analyze social behavior and psychological behavior. So for them, this was a major paradigm change. I think they'd changed the way they did their experiments. Now, the field exploded. There are still hundreds of papers being published every year using this approach. It's an interesting case study in science because basic scientists like myself don't believe that any of the oxytocin gets into the brain, because there's a blood-brain barrier. And so even though you put it up the nose, well, actually what goes up the nose doesn't get straight into the brain. It gets into the blood and doesn't reach the brain. And there's not really very much evidence that it does reach the brain. And so biologists like myself think that all of the effects that you're seeing of that oxytocin are actually effects on the periphery, because oxytocin receptors are all over the body. So there is and it is an interesting case study that two communities, the basic scientists and psychologists, have got completely different understanding of what oxytocin is and what these experiments involved and what they mean. And there is a kind of lack of communication between them. Okay? There is no mutual understanding between these two communities. So the evidence that they're using has radically different interpretations to those two communities. And it's a case study in paradigm change for the psychologists. It's a case study in mutual incomprehension. It's a case study in the different meanings of evidence.
So, and another question, is scientific terminology immune to ambiguity?
Well, it's certainly not immune to ambiguity. Again, scientific terminology changes again all the time. And often when scientific terminology is commonly used, it's often got multiple meanings. I mean, there are some very famous examples. I mean, gene, for instance, a gene has got many, many different meanings. And depending on which context it is, you're talking about something completely different. If you're talking to a molecular biologist, a gene is a protein coding sequence of the DNA. But actually, for genetic scientists, or even for other scientists, they will interpret a gene as being including a whole lot of regions outside that protein coding region, regions that define where the gene is expressed and how it's expressed. But of course, others, other evolutionary biologists, think of a gene as being encoding a trait tied in with function. These are mutually inconsistent understandings of the word, and yet we use them. But we understand in a particular context what people are talking about, and so we adjust our understanding of that word to that context. So these meanings change over time. It's very difficult to give a hard, strong definition of them.
Mm-hmm. So I would like to ask you now a little bit about how scientific knowledge is published and some issues with that. So when it comes to scientific papers, what are some of the main issues that you would say are there with scientific publication?
Well, we have huge problems at the moment. There's no doubt about that. The scientific literature is growing at a phenomenal rate. It's been growing exponentially with doubling time of about 8 years for the last 100 years or so. Mm-hmm. There's already a massive scientific literature, and it's increasing at a phenomenal rate. And so lots of problems at lots of levels. For a scientist, the simple problem is, how do you keep on top of it? Mm-hmm. You know, there's just so much being published. How on earth can you keep aware of even what's going on in your own field? And that's a really difficult problem. It's also a problem in other ways. In the scientific papers, the output is the currency of scientific careers. It's the route that gets them recognised, the route that gets them promoted. It's the means for expressing their arguments. They're a very important part of what science is about. But it's tied into the reward process in a rather kind of strange way. It always has been, in my experience, but how it's tied into the reward system has changed over time. There was a time in my own career and when I started out when certainly the number of papers you published was what mattered, mm-hmm. at the volume. But then, let me tell you how things changed. In those days, my first papers, they were single author papers. So I was the only author. But over time, there became multiple authors. So what happens when you have a paper with 10 authors? Well, the rules changed. So you divided each paper by 10 if there are 10 authors. So you got a tenth of the credit for it. On the other hand, if you shared it with other people, you'd have more publications. What did it mean? What did it mean? Is it better? And there was a tendency to what was called salami publishing in very small units, so you'd have lots of papers. In other words, the reward system corrupted the publication process. Mm. Now it's always corrupted it since then, but in different ways, because the rules by which publications are linked to reward are constantly changing. And at the moment, the rules by which publications are linked to reward are very much to do with where you publish. And now papers published in what are called high-impact journals are more valuable. So they're the most important for scientists to go along. Now, this is terribly corrupting for both the scientists and for the journals. Let me explain why I say that. First of all, why is it corrupting for the journals? Well, the journals now want to be understood as being high-impact journals. They want to publish papers with a large number of citations. Now, a highly cited paper isn't necessarily a good paper, not necessarily the best papers. In fact, very good, very important papers may often not be cited at all for many years because they are novel. A really novel paper won't be cited a lot until there are other people working in the same area that will cite it. So the problem is then the journals that want to be high impact journals won't really publish very novel work. They won't publish the replication work, which is very, very important for science. They won't publish challenging work. They tend not to publish work from scientists that aren't well known already, because a well-known scientist is more likely to be published. So journals, in other words, they are, if you like, to serve their own purpose of publishing highly cited papers, are very kind of increasingly restrictive on what they will accept for publication. Mm-hmm. Now, from the point of view of the scientist, it's corrupting as well, because that, in the same way, it changes the way you do science. In other words, you now start to construct science not to be good in itself, but to fill what you understand as being the kind of paper that the high-impact journals want. Mm-hmm. So, for me, it's kind of crazy. It's corrupting both the scientists and it's corrupting the journals. And always it is linked. If you link the number of citations, and if you imagine that is anything to do with the quality of the paper, then I think this is a delusion, an absolute delusion. It's not anything to do with the quality of the paper. If you want to know how good a scientific paper is, there is only one way you can do that, and that is to read it and use your brain and make a judgment as to whether it's a good paper, a solid paper or not. You wouldn't judge how good a paper is by counting the number of times it's been cited by other people. What sort of kind of is that intellectually sincere, honourable, and sensible? Of course not. So I think that there is something problematic about the culture of publications at the moment. And we have to find our way out of these two traps. What do we do about the volume of publications? How do we make it manageable? And how do we restore or bring integrity to the whole process of publication and value originality and quality, and break away from this metric of citations?
And do you have any idea, any suggestions about how we could do that?
Well, we have. I've raised two different things. I probably shouldn't have put them together. But if we look at the first one, which is the problem with the volume of the literature. Well, clearly what is becoming more and more important are the kind of review articles, reviews that attempt to gather together a lot of the primary research papers and present that objectively. Now, they can be very, very good, and they're certainly always very important because they're the way a lot of scientists get to know the literature, not directly through reading the primary papers, but by reading review articles. So this is an activity which needs to be given a lot of support, but it needs a rigor that is mostly missing at the moment. In some fields, in medicine, for instance, mm-hmm. the idea of systematic reviews and rigorous meta-analysis has become common. In other areas of science, they are now not common. But I think it is terribly important to, in fact, have a culture that brings rigor to the writing of reviews, so that reviews are meticulously systematic, they're exhaustive, they're proper surveys, and they're as unbiased and objective as is possible for those things, because people need that kind of objective, systematic synthesis of the literature to make sense of it moving forward. But we need to encourage that. No, we don't encourage that. Not in Britain, not generally. Review articles are not given the same value as primary publications. Primary publications are thought to be the important thing. Review articles are thought, well, anybody can write a review. That's not true. It isn't true. To write a good review takes a lot of time and a lot of expertise and a lot of scholarship, and we need to value those things. In the old days, it was called scholarship. We need to value scholarship more than anything. So that is one kind of important thing. In terms of the culture of citation metrics, there are moves to neutralize that. Some of the kind of grant funding bodies increasingly are insistent that the no attention should be paid to where a paper is published. And certainly in Britain now, for the big research assessment exercise, they are on the face of it, then research is reviewed without reference to where papers are published. Now that's important, but it's still not really understood that is the way things work. And I think we have to take that a lot more seriously. And I think it's for every individual scientist to do that. It's for every individual scientist to refuse to use citation metrics, to refuse to think about impact factor, just to refuse to discuss it, refuse to comment on that in promotion meetings, and just kill any conversation on it, just to say that, look, we're not going to use these metrics, they're just nonsense.
And do you think that in scientific publication it is easy to produce exaggerated claims and straight nonsense, or is it not?
Sadly, both of these are very easy to do. I mean, exaggerated claims are almost encouraged by the culture of publication at the moment, and that is new. Again, when I started out, the most important journal in the field was the Journal of Physiology. And the Journal of Physiology actually, almost as a matter of principle, refused to let people make strong claims. Everything had to be expressed cautiously, and they refused to have the claim in the title of a paper, for instance. Nowadays, the drive towards what's called high impact and high visibility encourages people to make very extravagant claims about everything that's done. And so journals encourage it. Authors encourage it, that they make these bold statements, and they're devaluing the whole process in doing so. In terms of nonsense, again, we have problems in our peer review system. Okay, and and the biggest problems are actually with the most, what I call the most high impact journals. Let me give you a clear example. There is a recipe for publishing in Nature and Science, for instance. It's well known, really, if you want to get a paper published in Nature, you need ideally you need a consortium of well-known people from different labs with different techniques coming together to produce all different pieces of a single story that you put. And so there's a planning. We should publish on this story in this way. We'll have this group contributing it, and they put it together and they send it off to Nature or Science. Now, can you imagine how hard it is to referee a paper like that? Each one of us really is a great expert in one or two techniques. You're confronted with a paper with 10 different techniques at the highest level. You know about your little bit, but not about the rest. And so it's actually very difficult to properly review these papers. And so what you often find is that these 10 parts of a story have all got problems, little problems, and they tend to go unnoticed. But I say they go unnoticed, but when I read a paper in Nature that covers an area that I know about, I'm usually very frustrated because I realise that bit that I know about is terrible. It's complete nonsense. So how did it get into Nature? Well, it got into Nature. Well, actually, the people that refereed the paper didn't know about that technique. They didn't know about that problem. So that's a problem. In the old days, papers had a single technique, and so the refereeing had several experts on that technique, and they could really interrogate it closely and find out the problems and defects with it. With a modern style of papers, it's much harder to do that.
And do you think there's something that could be done about that? I mean, in that regard, when it comes to that specific issue, do you think we should go back to how things used to be done?
In some ways, yeah. I think it would be better for science if papers that were published were focused on a particular methodological theme. Mm-hmm. There's the idea about at the moment that a case is made stronger by what's called triangulation. If you have three different pieces of evidence or more different pieces of evidence all pointing to the same conclusion, then the conclusion is somehow stronger. Well, yeah, that may be true if each of the bits of evidence was themselves very strong. But if you have four very weak pieces of evidence, you still have a very weak case. And I think it's much better to have streams of evidence which are strong and solid in particular technical approaches and that can be properly reviewed and properly understood and build up a case like that. So I can't see us going back to that easily, but I think that those are the best papers, and we should encourage papers like that.
Mm-hmm. So another question that also philosophers of science discuss a lot: what do you think about the demarcation problem and trying to separate what is science from what is pseudoscience or sometimes anti-science? Do you think that's something we should worry a lot about, that it should really be determined or not?
Well, this is kind of one of the kind of great and fundamental questions, I think. And now I think, Popper's style, Karl Popper, was I think the person that for me he was. I said that I came into science because partly of Thomas Kuhn's book, Structure of Scientific Revolutions. The other book that really inspired me was Karl Popper's The Logic of Scientific Discovery. And he was driven by this. He was driven by the, what distinguishes science from ideology. And I think Popper grew up in an environment where there were fascists and there were communists, and he was somehow aware that what I think struck him as a young man, as a child, was that these people with different ideologies were impervious to evidence, really. You couldn't say anything became a support for their own position. They'd reinterpret it and use it in that way. And so he came to the kind of important key belief that what distinguishes science from is that it can be disproved. It can be disproved by observations or experiments made in the real world. Okay, and that is what is important. A scientific statement is one that is falsifiable in that sense. There's the potential for it to be shown to be wrong. And people who make those scientific approaches understand that it could be wrong, and that their role really is to look for holes in arguments and look for ways in which it might be wrong. And that's what science is about. And I think that's very, very kind of important to distinguish the scientific attitude from, if you like, the committed ideologue who is impervious to facts or reason, won't change his mind, whatever you say. A scientist has to sign up to the possibility of being wrong. And I think a scientist has to be interested in the possibility of being wrong, ideally. Mm-hmm. It's an idealistic approach, but I think that's important.
But is science value-free or value-laden? And I mean, can it even be value-free?
Look, science is a human endeavor. Yeah. I think more than anything else. Science is what scientists do. You can't define science in any other way. And scientists are people with their own values, with their own prejudices, they're people of their own time. So the idea of having a kind of value-free science, although we might strive to be objective and unbiased, we can never escape from our own humanity, and we can never escape from the times that we're part of and the communities that we're part of. So we can never quite escape that. And there's no point in really trying too hard to do that, because science is a human creative enterprise.
And is there ideology in science? Because, I'm also asking you this because Just earlier, when you were talking about Karl Popper, you mentioned how he was so frustrated that he was exposed to so many ideological people in his time that were impervious to evidence, let's say. But is there also ideology in science?
Well, there certainly is, and I suppose it's in the nature of things that we tend not to see our own ideological blinkers in our own time because we're people of our time. And often we sometimes only see these flaws in retrospect. We understand when looking back at the history of science, how science was riven with racism, was riven with preconceptions about ethnic origins. And we see that in all sorts of areas. But I think at the time people simply didn't see it because it was part of the kind of accepted culture. Again, science is a human activity. We are obviously, I think, honest scientists strive to be unbiased, strive to be objective, but we shouldn't pretend that we are other than people of our time and our culture.
And taking into account what tends to be the communal aspect of science, of course, we've already touched a little bit on that earlier, and sometimes some people are more selfish than others, let's say. But do you think that it makes sense to look at the history of science as a series of achievements by individual geniuses? Does that make sense?
Well, I certainly don't think that makes sense. It makes a kind of convenient story, just as it's often convenient to understand history in terms of the succession of kings or whatever. But and we now, of course, the trouble is that understanding history as a sequence of kings ignores the common people that created the world and created the industry and created the countries and created the culture. I think the same is true in science, maybe even more so, in that a scientist cannot be a scientist is well known for being persuasive, persuading other people, and persuading their colleagues. That's how they become famous. From the papers they write, from the way they talk, they sell an idea. Now, the idea that they sell is always constructed from elements contributed by lots of other people. The evidence that they use to support it is often contributed by lots of other people, not just people they collaborate with, but people working in quite different areas. That sometimes people that have contributed to an argument by closing down blind alleys, by showing that something else is wrong. It's always a kind of massive collaborative, it's a massive communal enterprise. So any achievement is always really the achievement of a community. In fact, an individual scientist working on their own really couldn't do anything, not nowadays. You need to, in order to be recognized, there've got to be other people who are interested in your work, that those other people will be doing similar things, and what they do will be contributing to your argument and the whole case behind it. So I think to try and give the credit to individuals is almost always misguided. That isn't to say that there aren't very bright individuals and exceptional individuals. There are, but often there are exceptional and very bright individuals that are kind of hidden amongst the mass of people that contribute to an idea. And so I think it's usually invidious to try and pick people out. So when we kind of invite somebody to talk, you can invite them because they're a great talker. You can invite them because they make a good case. That's fine. But we should never forget that there are lots of people that are contributing to the development of an idea.
Mm-hmm. So I would like to ask you one question about science communication. Do you think that presenting science as narratives is a good way of communicating it? Can science be like storytelling or not?
Well, science is like, yes, of course. The thing about stories is that people like hearing stories, and you can learn a lot from stories. There's nothing wrong with storytelling. That's fine. But we have to know that people are telling stories. When we're scientists and listening to other scientists, we have to know that they're telling a story. And we have to be aware of that. And our job as scientists is to look for gaps and weaknesses in that story. We shouldn't be seduced by the fact that, oh, yes, that makes a nice, clear story. When we hear a good story, we should always kind of look for the holes and the problems and how it can be told a different way, and not just sit back and think, oh, gosh, what a wonderful story. Let's accept that. But stories are a good way of communicating. We remember stories. And that is why they're important. You know, in the end, if you give a talk, if I give a scientific talk, is it any scientist gives a talk, you want the audience to remember something. And if you tell a story, they will remember something. Okay, we remember stories. If you don't have a story, unfortunately, whatever you say, however important it is, people won't remember it. You won't have succeeded in persuading people.
Okay, great. So let me ask you now a question that comes from a Portuguese patron of mine, Eduardo Castro Mota. He basically would like to have your insight on how many times people tend to base more their opinions or the knowledge they get on authority, fame, and what he calls accessibility of information, like, for example, through social networks and AI tools like GPT, rather than basing themselves on evidence. Do you think that's correct? What are your thoughts on that?
That of course, that is true. And it's one of the kind of diseases of science, I think. You know, if you asked about the norms of science, and for many of us, we would say that we should not accept argument by authority, and that just because somebody is famous who's making a statement, we shouldn't accept that. We should actually look at the evidence behind what he's saying. Of course, it's an easy and lazy thing to skip that step and just accept what important people say. But it's fundamentally important to science that we don't do that. It's fundamentally important. We should not respect authority for its own sake. And in the book, I mean, I kind of give an example of that in the argument between Geoffrey Harris and Solly Zuckerman. Solly Zuckerman was the great authority, and he tried to impose that authority to squash Geoffrey Harris's ideas about the foundation of my field of neuroendocrinology. And it ended in a proper way. It ended by a scientific argument in public over the evidence between the two different positions, and that in the end was what resolved it. And Solly Zuckerman's authority did not prevail. that for me is a kind of inspiring and important message. And the young upstart Geoffrey Harris was the one that survived and endured and thrived. So it unfortunately, authority is given more respect than it should be. Well, you should respect everybody. Let's put it like that. We should respect everybody as individuals, but we shouldn't believe people because of their authority. And nor should we believe that a paper is good because it's published in a prestigious journal. Mm-hmm. In fact, all the studies have shown that the papers published in Nature and Science are less reliable than papers published in, for instance, society journals. And that is, we know the reasons for that. Often the first papers published in a particular field are likely to be unreliable. The first papers in a particular area that bring out with it a new idea are often small and effect sizes are exaggerated, and they are less likely to be reliable. And fraud is more common in papers in the higher impact journals. So just because a paper appears to have the authority of being published in Nature and Science, really we should put that to one side and actually look at the paper and judge it on its merits, what it says. So in terms of the profile on social media, which is another aspect, well, that is a novel thing, and it's really worrying. There's a view out there that scientists should go and promote themselves on Twitter and social media. Well, that's that's fine. But really, scientists shouldn't be getting their information about the scientific literature through Twitter. It's not an unbiased, systematic way of understanding the literature. There are good, systematic, unbiased ways of reviewing literature, systematic searches. There are tools like Web of Science that have got these things. You can search them systematically. You don't get your understanding of science by random feeds from your friends on Twitter, or maybe what you shouldn't do. And if people do get their understanding of science that way from Twitter, then we should be really seriously worried about it.
Mm-hmm. But I mean, Eduardo's question also has a second part, because he would like to try to understand why people have this tendency, or many people have this tendency to believe more on authorities, on famous people, believe in authorities or famous people than in evidence. I mean, does it have anything to do with cognitive laziness, or what do you think are the reasons behind it?
Well, it's in some ways it's understandable. It's not surprising. It's a shortage of time. The literature is enormous. People are looking for shortcuts.
Yeah.
If as I talked about earlier, I think I would hope we would invest in building up a culture of publishing objective, systematic, exhaustive reviews. That they're not very common at the moment, and that would be a way of giving a good shortcut, helping people accommodate a lot of knowledge quickly. But if you don't have that, then how do you find a shortcut? Well, one easy shortcut is just to listen to very well-known people. Another, maybe to pick up what is trending on social media. It's easier. It's easier than reading the original papers. I'm not promoting it. I think I think we should, in our education of scientists, really try and discourage this radically.
Okay, so one last question then, and taking into account what Eduardo asked. So, do you think there's anything people who are not scientists or part of the scientific community can do to deal with this massive amount of information that many times they, of course, due to no fault of their own, cannot really process adequately, or do not even have the proper training to evaluate?
This is really a very, very important question. Mm-hmm. Okay. So thanks for bringing it up. Yeah. So at the moment, there is something called the open access movement that scientists are now being encouraged and often mandated to publish in what are called open access journals. And these are journals that are free to read.
Right.
So they're, in principle, any member of the public can find out what they're doing. And the argument is sometimes made that the scientists are funded by the public, so the public's got a right to see what they do. Mm-hmm. Now, there are real problems with this. And the problems with it, as it is happening at the moment anyway, is that the research funders are demanding that primary research papers be published open access, but they're not demanding that review papers are. Now, let me explain about open access. Although they're free to the public, they're not free to the author. The author has to pay, or their institution has to pay, often quite a large amount. Now, institutions, therefore, are not likely to want to pay the open access fees for publishing reviews open access, because the research funders aren't providing the funds for it and they're not mandating it. But reviews are probably the best way of getting a good, balanced understanding of scientific progress out to the general public. So they're not really being supported by the open access movement, and they're not being prioritized. And if you really want open access for the public to understand what's going on, then what you need to do is to invest in making reviews, good reviews, accessible to the public. That means making them readable and understandable. That means putting investment into the production quality, putting a lot of editorial care into making them clear and accessible. That's the way of getting science out to the public, not by making the primary research. Primary research papers aren't written for the general public. They're not intended. They're written for other experts in that field who know about the technology and details. The general public, even not just the general public, even other scientists in other fields won't make much sense of most scientific papers. So making them open access is of pretty trivial value. So I think the open access movement in some ways has been misdirected. Its efforts ought to be in a completely different direction, just to make review articles objective, systematic, clear, and accessible to as many people as possible.
Mm-hmm. Very well. So, Dr. Leng, let's end the interview here then. The book is The Matter of Facts, Skepticism, Persuasion, and Evidence in Science. I'm leaving a link to it in the description box of this interview. Would you like to tell people, apart from the book, where they can find you and your work on the internet? Would you like to mention any places?
I think I'm still easy to get hold of on the internet. I think my email address is relatively easy to find, and I will always kind of respond to anybody that writes to me, and be very happy to hear any opinions about the book or anything I've said today or at any other time. And you'll also find a number of my kind of lectures available on YouTube if anybody has the stomach to see it more of me. Okay. Thanks very much, Ricardo. It's been a pleasure.
Thank you very much for your time, Dr. Leng. It's been my pleasure. Hi guys, thank you for watching the interview until the end. Please do not forget to share the video, subscribe to the channel, and also leave a like. And if you like what I'm doing, please consider supporting the show on Patreon or PayPal. You can find the links in the description box of the interview. This show is brought to you by Enlights Learning and Development Done Differently. Check their website at enlights.com. I would also like to give a huge thank you to my main patrons and PayPal supporters: Per Larsen, Jerry Mueller, Hans Fredrik Sunda, Bernardo Seixas, Olaf Alex, Jonathan Visser, Adam Kessel, Matthew Whitting, Bird Arno Wolf, Tim Hollis, Eric Alenia, John Connors, Philip Force Connolly, Robert Windager, Rui Inácio, Zup, Marco Neves, Colin Holbrook, Simon Columbus, Phil Kavanagh, Michael Stormir, Samuel Andrea, Francis Ford, Tiago Nunes, Alexander Dunbauer, Fergal Cusson, Hal Herzog, Nuno Machado, Jonathan Librant, João Linhares, Stanton T, Samuel Correa, Eric Hines, Mark Smith, João Eira, Tom Hummel, Sardas France, David Sloan Wilson, Yacila Dez Araújo, Romain Roach, Diego Londoño Correa, Yannick Punter, Adana Rusmani, Charlotte Bliss, Nicole Barbaro, Adam Hunt, Pavel Ostazewski, Nelek Bach, Guy Madison, Gary G. Elman, Simon Afzal, Adrian Yeagy, Nick Golden, Paulo Tolentino, João Barbosa, Julian Price, Edward Hall, Edin Bronner, Douglas Fry, Franca Bortolotti, Gabriel Panos Cortez, Ursula Litske, Scott, Zachary Fish, Tim Duffy, Sunny Smith, John Wiseman, Morten Eichland, Dr. Bird, Daniel Friedman, William Buckner, Mau Maria, Paul George Arnaud, Luke Loaki, Georgios Theophanos, Chris Williamson, Peter Wolozin, David Williams, Ruth Towell, Diogo Costa, Anton Erickson, Charles Murray, Alex Shaw, Amari Martinez, Coralie Chevalier, Pedro Bonilla, Ziegler, Bangalore Atheists, Larry D. Lee Jr., Old Herringbone, Sterry, Michael Bailey, Dan Sperber, Robert Grassis, Tom Roth, DRPMD, Igor N., Jeff McMahon, Jake Zool, Barnabas Radix, Mark Campbell, Richard Bowen, Thomas Dobner, Luke Neeson, Chris Story, and Manuel Oliveira. A special thanks to my producers, Isar Webb, Jim Frank, Lucas Stafiniak, Tom Vanagdam, Bernard Hughney, Curtis Dixon, Benedict Mueller, Vega Giddy, Thomas Turnbull, Catherine and Patrick Tobin, John Carlo Montenegro, Robert Lewis, and Al Nick Ortiz, and to my executive producers, Matthew Lavender, Sergio Codrian, and Bogdan Kanivets. Thank you for all.